Okay, so now what we've got is a 10K pot and a 9-volt battery, and the pot is wired to the battery as a potentiometer. The positive and negative leads from the battery are negative and positive. They go to the outside terminals, and then the positive side goes to this black wire and the wiper goes to this red wire. Okay, so those go over to the circuit, and we've removed the timer altogether. None of this is in the circuit. The black wire, which is going to the battery positive side of the pot, remember, is going to the function generator positive connection point. Okay, and the red wire, which is hooked to the pot wiper, is going over to the function generator minus point. Okay, through a 50 ohm resistor. Alright, and then over here on the scope we have the top trace is looking at that function generator plus point, like it always does, usually does, 5 volts per division, and the bottom trace is the common MOSFET drains, and it's at 50 volts per division, and it's showing battery voltage, which is supposed to be 50 volts if I had the battery voltmeter hooked up there. Okay, so there's the battery voltage right there. Okay, and so the MOSFET common drain, since the MOSFETs are off, the MOSFET common drain is showing that battery voltage. Now I'm going to turn the pot. Okay, so right now I've got the pot turned all the way clockwise, so these two guys are effectively shorted. So now I'm turning the pot counterclockwise, more and more and more. Oh, right there, you see the oscillations come in. You'll see first, you'll see the top trace drop down to only about 3.5 or 4 volts. It should be 9 volts, right? But it only goes to 3.5 or 4 volts, and then zoom, there's the oscillations as I increase further. Okay, beautiful, nice oscillations. Now we're looking at that at 0.1 millisecond or 100 microseconds per. So let's crank that on down and take a look at take a look at those oscillations. Okay, so right there, now we're at 1 microsecond per division, and we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20 and 2/3 in 8 major divisions, or 8 microseconds. So doing that math, you'll come out to 2.4, 2.5 megahertz, something like that. Alright, and notice how beautifully nice and sinusoidal appearing those are. There's not really very much distortion on that oscillation. Okay, so now we go back to where we were, and that's with the battery. Okay, now I've tried this by hooking up the battery, instead of using the 9-volt battery, just taking those positive and negative terminals and hooking them up to the lowest battery in the running stack, and it doesn't work. I get nothing. I'm not going to show that right now. You'll just have to take my word for it. But what I do want to show is this other thing where trying Mile High's idea of putting the bias battery in series with the lowest battery of the stack. And so what I've done here is that, of course, is going to involve putting the positive pole of this battery to the negative pole of that battery. And I've got a little jumper prepared there. And so that's what I'm going to do, is just do that. Black jumper to negative. Okay, boom. But as soon as I do that, watch what happens to the trace. This is really hard with one hand holding the camera. Okay, there. So you see what happens there? You get another kind of oscillation, right? Immediately when you hook up that battery like that, okay? Immediately when you hook that battery up, you get this other oscillation. Ooh, ah! I'm dropping stuff all over the place. This is not easy. Okay, so let me hook that up again. Alright, immediately when that's hooked up, you get this other oscillation here. And this does not depend at all on the setting of the pot. I can rack that pot all the way to one side, all the way to the other side, and there's no change. And we haven't really even made the circuit either, because one side of the battery terminal is disconnected. But there's that, and if I crank up the time base, I'm unable to resolve it. That is a higher frequency oscillation than this scope can display, and I'm seeing it at 0.1 microsecond. You can just barely see it, 0.1 microsecond per division. So this is exceeding the bandwidth of my oscilloscope. All right, so that's a second oscillation mode that essentially prevents me from hooking up this battery in series with the bottom of the stack. If I go ahead and make the other connection from here to here in order to actually do that, then you still see these oscillations, and you still cannot tune for the correct oscillations. Alright, thanks for watching. Oh, good oscillations. Here we are. Where are we again? Come on, good oscillations. Hook up the battery. Find the pot. And tune the pot. What has happened here? Did I come loose? Ah, that's what it was. I had a loose connection at the board. So now, tune the pot, and there's our oscillations right there. Okay, thanks for watching.